I am Michael Greenlee, and today is Wednesday, June 17th, and we're going to talk a little bit about Ralph loops. More specifically, not actual Ralph loops, but more human out-of-the-loop loops. And I think it's probably easiest just to kind of jump in and show you what I have going on. Okay, so I think it was in late April, it might have been in early May, Anthropic had announced that they were changing their the way that they were, the pricing, the way that they were handling usage. Specifically, what affected me was there is the Claude P where you can run Claude from the command line, and it just runs a single iteration and it returns the result. And this is what I had built my Ralph loops around. Not strictly that. You can specify that it needs to take a JSON schema, and I had built a harness around it that ran the prompt, in a way that it was repeatable. Okay. What I want to do, so when they made that announcement, then I made plans to jump over to Codex, and that is what I'm going to show you right now. But the way things work out in the AI world is that was supposed to take effect on Monday, and on Monday they announced that they weren't doing it. So I don't know if they've completely backed out of that plan or if they're going to modify it and change it. But regardless, I am going to show you my Ralph loop. Okay, a Ralph loop is an incredibly basic concept. The human out-of-the-loop version that I'm going to show you, it's not quite strictly a Ralph loop. But the way that mine works is you have the harness on the outside, which I've simply named Ralph, which is just a Go application that runs an agent in the background. You feed it a prompt. That prompt is instructed, in my case, that prompt is instructed to return one of two things, which is either it returns done or it says next, and the next is an indicator to run the next prompt in the sequence. So if I were to run my Ralph with prompt 1, prompt 2, prompt 3, what it's going to do is run prompt 1. If it exits with next, it'll run prompt 2, exits with next, prompt 3, and it'll continue that cycle as long as each of those prompts exits with next. If any of the prompts exit with done, then the sequence just stops, right? And so it can continue to run these. Now, the basic idea of a Ralph loop is that all of the state is on the disk, and you can basically start out with a completely clean context, and you can run the work in that loop, and then it can finish, and it'll make whatever changes it did on the file. The next loop starts up. Whatever changes are on the file system is what it starts with. It continues the work, and that keeps repeating. Okay, so more to the point here, I'm going to jump in and I'm going to show you what I have going on here. So I have two really dumb samples. Let's see, sample 1. And you can see that, let's remove count. And if we look at the loop prompt, so loop is the prompt. You're an autonomous agent. Do not pause for user input. Make the best available decisions and proceed. Perform exactly one iteration per invocation, then exit. Do not loop internally. You are re-invoked once per iteration, and all state persists in the workspace, not in your memory. And then for this iteration, it's being told to increment count. It's being told that its exit condition is 5. And my Ralph implementation actually uses the, you have the ability when you are running, in this case we're running Codex, you have the ability either for Codex or for Claude-P to specify that the input and output is done via JSON schema. And so we can generally trust that we're always going to get this piece of JSON back. It's going to have a status of either done, continue, done or continue. And a message about why it's doing it, right? So that's the way it works. Easiest just to show this thing in action. So if I say Ralph, actually I'm going to, let's take a quick look at, the way that Ralph works, what did I want? So we're going to do, okay, we're going to run it normal in verbose mode. Actually, let's just run it in normal mode. So this is what it looks like. We can reset it easy enough. So a couple different modes we can run this in. This is chat formatting. So it has JSON-L and chat format output. The idea behind the chat format is it's basically just showing you what the agent is doing. So here the agent ran a bash tool to run this command. So we're seeing the output of that bash tool. When it runs a tool that has output, we see the output immediately after it. And here you can see that it's having a little bit of conversation with us because of the strict formatting of the schema. Yeah, it's giving us a continue, saying, hey, I need to continue running, but here's a message for the time being. And you can see that it's walking through its iterations, right? So let's do it a little bit better. The very first one, it had to find the file was empty, and then it started iterating on it. And you can see after each iteration, right, we're getting a little bit of a summary of what's going on in terms of token usage and things like this. It eventually finishes, and we get the complete story right here, right? Okay. So now that was really simple. I want to jump over to sample 2. The idea with my Ralph loop, which isn't technically really a Ralph loop, the actual Ralph loop is literally you just put the agent in a while loop that never exits, and it keeps trying to refine the goal, right? This is pretty close. It just that it has an exit condition, right? That's the only difference. But the exit condition is unknown to the Ralph code. It can be whatever you want it to be. So let's take a look here. So I'm going to remove this count from a previous run. This one has a plan file, and this is closer to how I actually use it, right? And so it's a plan broken up into 6 phases, 0 through 5, and each phase tells it to do something, and then each phase is told to run, is told that it'll be, do a single thing. So if we look at the work prompt, this is the first prompt. It says, hey, grab the next uncompleted thing out of the plan, actually do that thing, and then just the same, return next or done, right? And then what's different here is that there is a verify prompt. And you can see that what its job is to verify that these are very convoluted and made up, but what its job is to verify that the work was done, and if the work is actually done, it checks the box, and it helps the whole sequence advance forward. And again, if you were to run these, if I do Ralph, and now that I have multiple prompts, it's going to be Ralph work MD and verify MD. So you just pass the prompts in the series, the sequence that it's supposed to run them. Same thing, it fires up, it's going to start working. But I actually want to show you a slightly different mode here. So if we do Ralph format equals JSON-L, verbose. Ralph is also something you can script around, and for anybody that's never seen the LLM conversation, what actually is going between you and the API, this is a really great place to start. It's showing you the literal messages that the Codex in this case is capturing in its conversation back and forth with the LLM. And so you can see the very, very raw message types here. So let's make it a little more readable. Right, so you can pipe this through JQ. And here you can see that, it's starting a new thread. Every session has an ID. Starting a new turn. It's actually, so here it's starting an item, which is a command execution. You could see that the item completes, which is the command execution. This is the message going back. You can actually see the message in here. So when I am running, so when we flip over and if I am running from this perspective, JQ does not like the chat format. When we're running it from this perspective, all that is going on is that I am capturing these message types, the JSON-L message types, and we have simply a decorator that knows how to present each message as it arrives. And there's only several message types, right? There's the one for running tools, the ones for manipulating files, et cetera, et cetera. There's really not that many message types, and so I create a decorator for each of those message types. Okay. This is my Ralp loop. This Ralp loop is a little bit rough. It's 1 day old, but I've done these a dozen different times, slightly different ways. This is one that I'm going to keep. Right now, this one only supports Codex. I was making it to support Codex because I thought Claude was losing support for this. Turns out that it's not. Somewhere in the next few days, I'll come back and I'll add in support for Claude to run through this as well. But this is real and permanent, and it's well enough written that it can be shared, and I will continue to develop it. So it is available at Ikigenba Ralp. It is not special. The first time somebody goes to create one of these, it might take you an hour or two, but then you're going to find you're going to want to refine it a little bit. Even this very refined version probably was about 3 hours yesterday for me to put it together, and it is quite robust and refined, and handles all the different message types and errors pretty well. Okay, so I want to show a little bit about how well, first, I kind of want to reiterate that what this is a building block. It has almost no opinion about the layout of your repos, about how you do workflows. It just doesn't care. All it does is run a prompt, then the next prompt, and it keeps on going until nothing says done. It just keeps looping through the sequence. That's all it does. And on top of that, you can build almost anything. And so I want to share a little bit about how I actually do use this building block. So I want to git clone. So IDGen is another tool that is in an Ikigenba repo. IDGen, here, let's just do this. So first, let's clone it. But before I drop in and look at it, let's just look. I obviously have one installed, so I can just do idgen help. What idgen is simply, in fact, I'll just run it once. What idgen does is simply return a unique ID. Of course, I could have used a UUID. I just get really sick of those giant IDs, and so this returns a unique ID in a shorter format that I can sprinkle through my code, which I'll share here, and I'll show why in a second. Okay, so if I drop into idgen and do a tree here, this is the entire thing. I intentionally shipped no source code. If you wanted to build this thing, you would need to check this out and then simply do Ralp prompts loop, and then prompts verify. Actually, no, this one actually only needs loop. Verify is a completely different thing. So you could run this, and it will take about several minutes. It's going to burn, pretty moderate amount of tokens. It isn't too bad at all. It won't even show up as a blip if you're running a max account or a pro account or whatever the Codex version is. You won't even notice it on the meter in the UI. But what it's going to do here, you can see it's doing real work, right? It's still in chat mode, still the same thing. And you can see that it's actually, starting to process this whole work. It's reading all the different files. It read the, up here, I imagine one of the first things it probably did was, so it read the plan file here, because this one has a plan file, and that's what I'm going to show. And then, it read, what did it do here? Oh, so it was largely looking for requirements, right? So that's what I'm going to show here in a second. Anyway, it started working on it. It changed a whole bunch of files. It did the iterations. Okay. That is, it would complete if I let it. You can see it started to build out the code. Did it? I want to see if it... I want to drop back to I want to go back to the empty directory here, so idgen, so it's easier for me to show how this works. Okay, how I actually use it, and this is constantly evolving too. Crap. I just want to do this so it's easier to, there we go. So this is what I wanted to be able to share. In the docs folder, I have a product file, a design, and a plan. I sometimes have a research file in here as well. And I have corresponding skills that help me build those files. These are really typically in my, my user level Claude folder or Codex folder. But in this case, I stuffed them into this repo so that we could see them. Effectively, what these are is they're interactive. They're prompts to be interactive. So when I enter, typically I would start by entering product mode. And what this is going to be is just going to be it's going to interrogate you about what it is you're making. And then it's going to record that information in this product file. And so the product file has you can see it has a particular layout, right? So it's going to take whatever you're doing. It's going to interrogate you about it. In this case, this thing is ID gen, right? And what its purpose is to generate these IDs, but it describes how that file should be created, and it interrogates you to make that file. And now the same is true of research mode. Sometimes, obviously doing development, you realize that neither you nor the agent has the current context, the information that you need to be able to do a thing. So you go out on the web and you collect research. And an example from doing Ralp was it doesn't have up-to-date information about all the API pricing, but yet we're collecting the cost data back, and so we have to go out and do a little research to build up the pricing table so it knows how to do that. We also have to do research to make sure that we know all the different options that you can pass through and things like that. So we collected some of that in the research file. Again, that's an interactive one. And both research, product, and design, they are all re-entrant. So you can re-enter those at any time. You can add a new design piece, right? Or do more research or build more plan. The one that is a little bit different, build more design. The one that is a little bit different is plan mode. So I'm going to open up docs plan. This is just the way that I am doing these things. Remember, Ralp is agnostic. It doesn't care. You just have to make the loop prompt match whatever your workflow is. As long as those two things are aligned, Ralph will iterate through it. But the way that I do the plan is slightly different than the other documents. Plan is strictly append only, and plan is strictly append only, and you can see that these ones are marked as incomplete right now. And so it would come in here and put a green checkbox in that and change it from not started to complete as it was working through each of these phases. And that's how the loop instructs it to track its progress. And so if I come along later, let's say the product has been delivered, if I come along later, I can add to the research and design and product file, make them more complete. I can append more work to the plan file, and then just rerun Ralph, right? And so these are the interactive parts. You tend to get them all built up. You run Ralph, you walk away, is really how this works. And what else is there? In this in my Ralph implementation, I collect data about the runs so that you can go back and look at the cumulative spend and token use and stuff like that. So you can you can have something read this and generate a graph or whatever you want to do. And it also includes the well, I think that's probably all there is to say about that. Okay, so that is the Ralph loop that I use, how it works, and the real distinguishing thing is this is on the outside, and so it can loop infinitely. There's never going to be any corruption. It always starts with 0 context. It loads the files and the state from disk. And gives you a nice pretty feedback while you're doing it. And you can do these on the simple in a few dozen lines of code, but I actually do find that being able to watch, so if we do Ralph props loop, I actually do find that being able to watch it occasionally is very helpful, right? So when you're 6 hours into a run, you can stop in front of it and read it for a few minutes, and you have an idea as to whether it's still doing intelligent things or if it's completely off the rails. And I personally find that very, very useful. You also know it's not just stuck, right? Because you're getting some feedback about what's going on. You can see what commands it's running, what it's doing, etc., etc. Okay, that is a little tour of my Ralph loop. It's not so much that I recommend you would come use my Ralph loop. It's more that I recommend that you figure out how to generate and use your own kind of human out of the loop. You want both human in the loop loops and you want human out of the loop loops. There are two different tools that are used in two different ways. Oh, I did not focus in on one real quick change here. Maybe we'll see it. So it's starting to make some files. So, but it probably isn't going to have any test files yet. So I'm just going to stop that, and I am going to take a look at docs. I kind of wanted to share how I actually use it, right? And what you'll find is in the design docs, it's broken up. It describes features, and then there's a verification section in that feature description. And that verification description includes a bunch of these requirement IDs. What Ralph is asked to do while working on this is to add those requirement IDs as comments, to annotate the code with them. The test code demonstrating that required verification is implemented. Now, I'm still using agents on their, running on their own here. And of course, it can copy paste that requirement ID into the code and never actually have solved or delivered that feature, right? But what it does is by having the documented trail of the verification IDs, these are all the things that we want to verify. Somewhere in the code it says it's done. When I go and run a third party agent now, not the one that did the building, and ideally, especially if it's available, you use one from a different provider. Now it can go do the verification. I can build a Ralp loop around it. I can say, hey, for every requirement ID, actually go take a look at the code and make sure that the test actually satisfies the verification requirement, right? So you're asking it, does this make sense, or is it just a rubber stamp in the wrong place? And so you can use another agent easily to audit. So this is my actual preferred workflow right now, which is that essentially you do it in plan mode. You build a plan, but you also stamp it with the requirement IDs, and you can audit those requirement IDs. And the reason I've come to this is the other. I haven't tried them all, obviously, but every single bigger framework that I've tried for spec-driven development burns tokens at a rate of 10x this. And the way that this works, so you're breaking up the development work into chunks that fit into context. So that means there's less churn. It's not restarting as often. There's only 4 or 5 phases. Let's take a look, maybe 6. So if I go to docs and plan, and here you can see, because we had started it, right, I had flipped that one to done, but there's phase 1 through 4 only, right? And so that means that it only populates its context 4 times to do all the work to make the whole program. But at the same time, there's something on the order of 30 or 40 requirements. If you were driving these requirements through some other spec-driven tooling, it's probably going to churn and build up tons of context and touch files 30 or 40 times, because that's how many requirements there are, and the token spend is just ridiculous. So with this, I find the perfect balance of auditability and token spend. Combine that, I don't know where I was going there. This has you're intentionally scaling what it can do, the phases, to how big context is, right? There is a limit to how big of a project this can do. Probably something on the order of 30 or 40 phases, 30 or 40 major steps like these phases. And it starts to lose coherence because it can't fit enough into context to understand the relationships between everything. And so that is actually quite large. It's generally larger than any specific module or library in a larger application or a service should ever be. And so then the breakdown of this is this scales well above the size of components. So you use this for the components, and then you use, then in the one level up application where you're assembling the components, they have no problem understanding the interface between all of the components, right? And so you just do layered software development exactly as you would do it for a human. These things are better, the models at this point are better at holding even more context in your head than you can. And so it's not a limitation, is what I'm saying. It's intentionally structured. Loop over a simple plan that has a design that has auditable requirement IDs, that scales up to as big as a component should ever be. And then you layer together components that are built the exact same way. And when you build that top level, you use the exact same system, right? That is the way that I am building software these days. And It fits directly into my hypothesis, which is that anytime we spend building crutches, complex spec-driven systems, crutch, anytime we spend time building crutches for the LLMs is wasted time right now, because they're getting better at a rate that exceeds the maintainability of these complex systems, right? This is simple. It is run a bunch of prompts in sequence. The prompts are tied to the project, to the, maybe I didn't look at that enough, but let's go back to look at IDGen and Vim prompts. And we have our loop prompt. This file is the only thing that it's tied to the structure. It explains the structure of what's in the docs folder, the plan, the product, and the design file, etc., right? And how to use them. They all live in the project. They're not all that, the tool that loops over these is not all that smart. You absolutely could just run Claude and say, read the, in fact, I should, if I had practiced it, I would try it, but it'd probably go off the rails. What you would do is you would run Claude or Codex, and you would say, run a subagent with this prompt, until you basically would do it as a goal or a loop, run a subagent with this prompt until the end condition is met. And it would be able to do it without Ralp. It's just that I find there are certain niceties that are built into Ralp. It's keeping a log. I know what I'm spending. It's formatting the output. That's really easy to read. It's not hiding it, et cetera, et cetera. Okay, I talked way too much. This was my explanation of how I do loops. So thank you, and see you next time.